Open Sensor Network. This is a very new project we're currently undertaking. It's started in August and it's going to end in March next year. Again, this is a collaboration between SEMI, Valet, Collage Boreal, and Symboticware. The goal of this project is, again, to address the fact that there's a lot of proprietary systems out there. And this is not in the context of a data logger or a SymBot or something else. This is more to do with location tracking. So there's location tracking systems out there. Specifically, big company names are AeroScout, Ekahau. They make something called Wi-Fi RFID tags, and these are used to track assets underground, on surface, in a variety of situations. The biggest problem with that, or with these systems that are out there, is that AeroScout will not interface with Ekahau systems, Ekahau will not interface with AeroScout systems, and so on. These are just two companies I'm picking. They will ask you to buy their hardware, their software, all the infrastructure around the same company. Now that creates a big vendor lock-in. If one company X and just goes and buys one system, they have to stick with it or undergo a major infrastructure change. So what we are proposing is the creation of a Wi-Fi tag with an open messaging structure. In this case, the messaging structure is published. We interface with other vendors, so we allow them to use our tag, or we can provide our own software to provide tracking for our tags. To take it a step further, we're also introducing Zigbee networks into the game. Zigbee is a new technology. It's similar to Wi-Fi, same radio, 2.4 gigahertz. But the biggest advantage of Zigbee is mesh networks. So what that means is that there is not just a single connection between two nodes, but there are multiple connections. Especially in an underground environment with a poor signal, for the poor signal quality, that is a critical factor. You can have multiple routes to the same destination, better connectivity. And also, the other factor is that in mining, infrastructure does not always keep up with the mining. So you could have new drifts coming up, and you cannot really lay access points for Wi-Fi everywhere. That's really expensive. So with Zigbee, these are very, very low-cost devices, and they can be deployed really quickly for a very low cost, and critical data can be transferred even in a mine which is expanding at a rapid pace. Again, take it another step further, and we combine the Zigbee networks with existing Wi-Fi networks. So what this gives us is a very low-cost, wide coverage network. And if we were to just look at this little diagram here, can you still hear me? So we have a network of Zigbee meshes, so all the little blobs with Zigbee written on them, and we have a Wi-Fi access point at the end of the drift here. So let's just consider that this is new infrastructure laid down. There was no time or money to install Wi-Fi infrastructure, but you're still getting critical data through the Zigbee network. And you do not need access points. The nodes transfer between themselves. So it's almost like a daisy chain. And it comes up to a big Wi-Fi hotspot and goes to the data management systems again. Applications. So apart from the applications that our projects describe, the SymBot has a lot more applications. Some of these are side effects of the project. Some of these are just requirements that we thought were very important. Engine performance monitoring. This is a side effect of the Pando and the CAF projects for us. In this case, the SymBot interfaces with a multitude of engines, so you'll have just engines which conform to the CAN bus or JSON 1939 protocols. Or we interface with CAT engines, where we employ our own software and hardware to read the CAT engine data and provide it to data management system. Automated activity monitoring. This doesn't really mean literally that we're monitoring everything the LHD or any other equipment is doing. This is more related to gathering data from operators. So just to give you an example, operators fill out a scoop slip when they're doing a circle check or a pre-check of their vehicle. They do that, and they're also filling out production data. In this case, what we do is, first of all, we automate the process. So instead of using a paper-based system, they just enter it on a screen. The SymBot grabs it and puts it into a data management system. And also, we pre-populate as much as we can. So if we have data about where the vehicle is, what it's doing, we pre-populate that and reduce work for the operator. Real-time vehicle location, that again ties into automated activity monitoring. So again, we use RFID tags to find out where the vehicle is and use that to monitor what it's doing. These applications are a little different. They haven't been highlighted in some of our projects. Asset health monitoring, this is a little classier name from our perspective for condition monitoring. Condition monitoring is monitoring all aspects of a mobile piece of equipment. This includes engine, vibration, mechanical aspects. And what this allows is, instead of using a set parameter, so saying a 250-hour service or a 400-hour service, you can go on service based on the condition of the vehicle. And this is all provided to managers, supervisors, operators in real time. So you can see if a brake is failing, you can see if the temperatures in the oil pressure is too high, and you can do service based on that rather than just a regular schedule. Because I think the one thing to keep in mind is not all pieces of equipment are the same. They don't have the same service requirements, and they do not need to go in at the same time, not necessarily. Portable air quality stations. These are an extension of our emission monitoring systems. So instead of having it on mobile equipment, we have these stations, or these are essentially boxes you can mount anywhere, and they will monitor the essential parameters: carbon monoxide, dioxide, nitrogen, oxygen temperatures. So I think the goal for this application is that if you have a newer drift coming up, or if there's work going on where there's no infrastructure, you can just mount this there, keep it for a few weeks, and if things advance, you can just move it. So it's not a fixed piece of infrastructure. You can move it around, relatively easy to move around, collects data, and if there is Wi-Fi, it will transmit it out too. Dynamic load weighing system. This is the last application I'll be talking about. I know it's probably getting a little quiet here. But this is very much under development. We do not claim that this is done. It's a very experimental thing for us. Just to give you some context, right now, and this specifically applies to scoops or LHDs, right now the systems that are in place, they require that the LHD be static, or be stopped for 15 to 20 seconds to get the load weighing in the bucket. So if the bucket is, say, 4 tons or 5 tons, the LHD needs to stop, take a measurement, and move on. Now, 15 to 20 seconds doesn't seem like a lot to us, but over a period of a shift, a week, or a few months, that's a lot, and it adds up given the number of cycles per shift, which are looking at 80 to 100 cycles. So what we are proposing to do is a dynamic load weighing system. In this case, the machine does not need to stop. We will be, and the biggest concern there is there's a lot of noise when the machine is moving. There's bumps, there's vibration, there are other considerations. What we will be doing is we'll measure the noise, and we will account for it in our calculations. So if we measure noise, we'll take it out of our calculations and provide a corrected reading for weight. And that saves a lot of production time, and then at the end of the day, it saves money. Now, I'm not going to talk about the next few slides. Bora will do that. Again, those are very funny slides. I really cannot handle them. So I'll just pass it on to Bora. I hope you enjoyed what I just mentioned.